Welcome to this webinar on the road to renewable energy. My name is Matt McHale, and I will be hosting today's webinar. Several quick items of business before we get started. If you have any technical difficulties accessing or hearing this presentation, use the chat pad and we'll try to correct them promptly. We'll wait to answer any specific questions until the end of the presentation, since that will allow us to move through the material efficiently and allow enough time for questions and answers. The presentation will last approximately 50 minutes, followed by a Q&A period. The complete webinar will also be loaded on the PennTAP website. The intent of today's webinar is to discuss how to combine energy efficiency, energy management systems, and renewable energy to achieve your energy sourcing goals at the lowest possible cost. This process is what we are calling the road to renewable energy. The format we will be following is to first explain our vision of the road to renewables, and then to briefly discuss the following related topics: energy baselines, energy efficiency, energy management systems, clean energy opportunities, funding for implementation, and PennTAP Services. At this point, we'll begin the main body of our presentation. I would like to start with the question, what is the road to renewables? In the next few slides, I will provide our answer to that question. Consider this scenario, which you may have encountered in your own organization. The president of ABC Company makes this announcement at a senior staff meeting. I want ABC Company to use renewable power for 50% of our energy needs by 2025 while increasing our profitability and competitiveness. How do we get there? How would you answer this question? One option would be to simply purchase a renewable energy system large enough to meet 50% of your current demand. This would require a large initial investment. Can your company afford it? You may enjoy some savings, but it could take many years for the investment to pay for itself. How will your company finance that investment while remaining competitive? Also, what will you do if your energy consumption grows? Will you have to invest in a larger renewable energy system to continue meeting your goal? This approach is not cost-effective or sustainable. The road to renewables is our term for a process that will enable you to meet your clean energy goals at the lowest cost. Instead of starting with a renewable energy investment, you should first identify low or no cost steps you can take to reduce your energy demand. The first step is to understand how you are currently using energy throughout your organization. Next, you can use that data to identify opportunities to reduce your energy consumption. Quantifying these opportunities will enable you to identify what set of actions will give you the largest energy savings at the lowest cost. Once you've taken these steps, you need to establish a system to continuously monitor and improve your energy performance. Since you have reduced your company's energy consumption, you will need much less renewable energy to meet your goal. You will be able to manage your energy usage into the future so you can sustain your commitment to renewable energy in a cost-effective way. This is our vision of the road to renewables, a cost-effective and sustainable path to meeting your energy sourcing and usage goals. In the next section of this presentation, we will describe each of these steps in more detail. The first step on this path is to understand how your organization uses energy right now. We call this establishing an energy baseline, which encompasses all of your current sources and uses of energy. We begin by creating a high-level picture of energy consumption at a facility. Utility bills provide a starting point for this analysis. First, we take a look at monthly trends in energy consumption from different sources. These trends give a sense of total energy need and the seasonality of the operation. They may also provide some early indication of what is driving energy demand at the facility and what types of clean energy sourcing options might be most appropriate. In this example, we see a typical pattern of high gas consumption in cold months, followed by increasing electricity demand in spring and summer. This suggests that indoor climate control drives a large portion of the energy demand for this site. This also suggests that the demand profile may be a fit for photovoltaic power, since electricity demand increases during the months in the summer with the most sunlight. You may see a different pattern of consumption in a manufacturing facility that does the majority of its production in the winter months. They may experience peaking electricity demand in the winter. We can add much more detail to this picture using power logging equipment. These tools can provide high-resolution measurements of energy consumption over short intervals, for example, from every second to every 20 minutes. These measurements could be taken either for individual pieces of equipment or an entire facility. This data can reveal short-term trends in demand, such as the difference between daytime and nighttime consumption, or weekday and weekend consumption. Unexpected loads during non-business hours could reveal opportunities for energy savings. Air leaks, for example, may become apparent when compressors continue to cycle on and off when production is halted over a weekend. Power logging data can also help identify sources of peak loads. These may only last for a short period of time, but can represent a significant portion of the overall energy cost for a facility. The detailed demand profile provided by power logs can also provide insights into the main benefits of a renewable energy installation. Peak loads may coincide or may not coincide with peak renewable energy production, for example. In some cases, utilities can provide site billing data in 15-minute intervals, which may enable similar analyses without additional monitoring equipment. Once the current baseline has been assessed, the next step is to identify opportunities to lower the energy usage and prioritize those opportunities according to the cost per unit of energy saved. In most cases, saving energy will be less expensive than producing it. Once you've identified and pursued all of your energy savings opportunities, you can consider how you want to meet the remainder of your energy demand. This will take you to the lowest cost solution for meeting your energy sourcing goals. The next slides will briefly discuss common energy saving opportunities and manufacturers. First, let's talk about improving efficiency with lighting upgrades and controls. The first step is to walk around your facility and note the types of lighting fixtures that are installed. Do you find many fluorescent tube lights such as T12s, T8s, and T5s in your warehouses, offices, or production floors? In your high bay areas, do you see high-pressure sodium vapor or metal halide bulbs and fixtures? Are incandescent bulbs or CFLs providing lighting in your hallways or storage rooms? You should also consider whether existing fixtures provide too much or too little lighting in each area. LED bulbs can provide appropriate lighting replacements for any workspace while consuming much less power than other bulb types. LEDs compatible with many fixture types are available. Here are a few LED types that can replace common incandescent, fluorescent, high-pressure sodium, and metal halide bulbs. The quality and quantity of illumination can improve dramatically when LEDs replace older bulb types. These illustrations show the dramatic improvement in illumination provided by LEDs that replaced high-pressure sodium bulbs. These images show LED replacements for fluorescent bulbs in an office and a production workspace. The best lighting for your workplace may be natural illumination. Skylights and windows can reduce your demand for artificial lighting. They can also improve productivity and make your work environment more comfortable for employees. Here you see an example of natural lighting through skylights in a single-story workplace. Even rooms that lack direct access to an exterior wall or rooftop can utilize natural lighting that is piped in from the outdoors into the building. These illustrations show solar tubes that channel natural light into these hard-to-reach locations. Here you can see a close-up of the external fixtures. In some situations, lighting is necessary around the clock. You may have many illuminated exit signs in your facility, for example. Replacing these signs with LED exit signs can both reduce your energy consumption and provide more reliable illumination for a critical piece of safety equipment. LED exit signs use 5 watts of power and last over 10 years. Most lighting is not needed as often, but relying on individuals to switch lighting off and on as needed may not be practical in every setting. Occupancy sensors in restrooms, offices, conference rooms, and warehouses can provide significant energy savings with or without a lighting upgrade. Before upgrading your lighting, consider whether the current placement and illumination levels of your lighting system match your needs. If you have changed the layout or location of your production and storage areas, you may find a mismatch between the original lighting design and your current workspace. Many contractors will provide free assessments of your lighting to identify these problems. Lighting upgrades offer short payback periods on small investments and provide visible results beyond energy savings. They can also be scaled to fit within budget constraints. Grants and rebates can further reduce the cost of these projects. The experience of Penn-Troy, a valve manufacturer, illustrates these points. PennTAP helped Penn-Troy apply for the Rural Energy for America program, grant and upgrades their facility to an LED lighting system. Penn-Troy is expected to save 187 million British thermal units per year, equivalent to $7,000 per year, as a result of the upgrade. The USDA REAP grant could pay up to $3,800 for the project, creating a payback period of 1.6 years. Some energy-saving opportunities are not as visible as lighting, but can still have a significant impact on your work environment and energy costs. Your building envelope includes all the walls, roofing, doors, windows, and other structural components that keep air you heat and cool inside the building. Every cubic foot of air you heat and cool costs money to produce. You can't see it, but the flow of that air from your building can represent a significant cost. This infrared photo shows exactly where heat loss is occurring at this building. Look at the heat from the windows and doors. This picture provides an overview of where you should look for potential building envelope improvements. Inadequate door seals open long, narrow gaps that may add up to a significant total area for air to escape. Small gaps like these around a single door can add up to a cross-section the size of a softball or larger. Imagine a softball-size hole in the middle of each door. How much air do you think could escape through that hole? Windows in poor condition can allow conditioned air to escape. Fogging can be a sign that seals are broken. You may find inoperable windows that cannot completely close. An open window can also be a sign that a room receives too much heat to be comfortable. You may also find other openings through exterior walls that may be less noticeable, such as pipe penetrations or ventilation access that remains open while not in use. Smaller gaps caused by missing seals, caulk, or cracks can also let conditioned air escape. Building envelope repairs and upgrades can also have short payback periods without large initial investments. PennTAP helped Kurtz Brothers, a school supply company, realize a total short-term annual savings of $12,000 by adding insulation and controlled heating with a payback of just over 1 year. This discussion of building envelopes makes it clear that conditioned air is a valuable commodity. Manufacturers also use a great deal of compressed air to operate their equipment. Compressing air requires energy, and that energy can represent a significant cost to a facility. In the next few slides, we will discuss how to save energy by managing compressed air use. An important first step in managing this cost is to understand just how much you are spending to supply compressed air. Periodically monitoring the compressor operating hours and duty cycle will provide the data you need to estimate your total consumption and the associated costs. You may be able to estimate your total leak loss by observing compressor operations during shutdown periods when you would not expect any demand for the compressed air. This provides a baseline to measure improvements in performance and savings. The next steps include finding and fixing leaks, eliminating inappropriate uses, and matching system supply with demand. The last step is to incorporate these practices into a plant-wide compressed air management policy. An average plant without leak management can waste up to 20 to 30% of its total compressed air capacity. This means compressors run longer than necessary and consume more energy. A leak repair program can greatly reduce that unnecessary energy consumption. The ultrasonic leak detector shown here can aid in locating leaks even in a noisy factory environment and can speed up the process of finding and repairing leaks. There are two basic types of leak repair programs: the leak tag program and the seek and repair program. In a tag program, leaks found in the course of routine work are tagged and repaired later by maintenance personnel. In a seek and repair program, maintenance sweeps the facility to search for leaks and repairs them as they are found. With either approach, the following steps will maximize the benefits of your program. First, establish your compressed air usage baseline. Then, estimate the volume and cost of your leak losses. This will give you a rough idea of the potential for savings. Next, identify and document leaks. After that, prioritize and carry out leak repairs. Then compare your improved performance against your baseline. How much of the potential savings have you realized? Then repeat this process. The lost energy and cost of leaks can be significant, and they increase dramatically with the size of the leak. This chart provides examples of just how much these leaks can cost you every year. It drives home the point that compressed air is a valuable commodity. Since compressed air is valuable, make sure you only use it in applications that work most efficiently with compressed air. This table provides examples of inefficient uses of compressed air, along with alternatives that are effective and efficient. Walk through your plant and identify all compressed air uses and, if possible, the flow and pressure requirements of each use. Take steps to eliminate any inappropriate uses. You may want to consult with a compressed air system specialist to see if other equipment, such as blowers, mechanical, or hydraulic devices, will be more cost-effective for those applications. There are other steps you can take to reduce the energy demand and cost of providing compressed air. You can reduce air intake temperature, reduce pressure, provide adequate storage, and apply appropriate air treatments. Investments in managing your compressed air pay off quickly. PennTAP completed a lighting assessment and compressed air leak check at the Dauphin Precision Tool facilities. The assessment shows that Dauphin Precision Tool can realize an annual savings of $1,900 per year by fixing compressed air leaks, with a payback period of less than 1 year. In the next few slides, we will discuss energy-saving opportunities related to HVAC systems. The most common HVAC units are packaged air conditioners with gas furnaces or heat pumps with either a gas furnace or auxiliary electric strip heating. They are typically controlled by wall-mounted thermostats. These systems require proper maintenance to perform efficiently. There are several maintenance activities for your HVAC system that can save energy and money. First, check filters every 3 months and replace them if necessary. Tune up your HVAC equipment yearly. Look for missing or damaged panels. Check for oil leaks or drips from the refrigeration components. Clean and clear debris from equipment. Programmable thermostats can also provide significant savings. In the winter, set your thermostat to 68 degrees Fahrenheit during operating hours and to 55 at other times. As with compressed air, you want to make sure you're not losing air to leaks. Seal your heating and cooling ducts. You can also consider bigger changes to your equipment to improve efficiency. For example, investing in an economizer can allow the use of outside air for cooling load when conditions allow. Some other common maintenance issues are broken or disconnected linkages and jammed or frozen outdoor air dampers. HVAC upgrades require more of an investment than some of the other measures we have discussed, but short payback periods are still possible. PennTAP analysis determined that Mitcheltree could save over $100,000 per year by installing a high-efficiency natural gas heating system. Mitcheltree received a grant of more than $13,000 for its $55,000 project to upgrade the heating system to natural gas. This resulted in a payback period of half a year. In the next few slides, we will shift to the topic of boilers and process heating. This is a typical boiler setup. For boilers, the main energy-saving opportunities are at the boiler, steam traps, and pipes. Big energy savings can be achieved by properly monitoring, adjusting, and controlling boilers, steam traps, and hot water pipes and systems. Each boiler and steam or water distribution system is unique, but some common general signs of energy waste are leaks of steam or hot water, loose or missing insulation, steam pressure that is higher than needed, malfunctioning steam traps, and high stack temperatures for boilers. The general signs above give an indication of the energy savings opportunities available. There are a number of steps you can take to save energy and money. Operate boilers at their most efficient operating range, usually between 60 to 90% full load. Reduce steam pressure. Lower pressure in 5 psi increments and allow the boiler to operate for several days to see if the system operates acceptably. Boilers operate more efficiently at lower pressure. Each 40 psi drop provides a 1% increase in efficiency. Get a consultant or supplier to measure flue gas or get a flue gas analyzer and measure it yourself. Most boilers lose between 15 to 20% of fuel input energy up the stack. This is called flue gas loss. Boiler efficiency should be 80% or higher. You should analyze flue gases every 6 months to identify when it's time for a boiler tune-up. A boiler tune-up will improve combustion efficiency about 2 to 5% for a 2 to 5% savings in energy costs. Here are some more saving opportunities. Consider installing economizers to preheat boiler feed water. Clean boiler tubes and check for broken baffles. Install thermometers in the stack to monitor flue gas temperature. Rising flue gas temperature indicates when boiler cleaning is required. Implement a water treatment program to prevent scale and corrosion in the boiler. Have a service technician perform periodic boiler blowdowns to purge solids and particles. These steps can result in significant savings and a quick payback period on your investment. PennTAP visited the Castle Co-Packers facility to assess boiler combustion efficiency, evaluate heat loss from uninsulated piping, and find opportunities to recover waste heat. Based on PennTAP recommendations, Castle Co-Packers would be able to save $25,000 per year in natural gas costs, with a 6-month payback on their investment. We've taken you through the first 2 steps on the road to renewables: establishing your energy baseline and improving your energy efficiency. The last step before considering clean energy options is to establish an energy management system. The examples of energy savings we have discussed make one point clear. Your energy costs are driven not only by what equipment you use, but how you use it and how you maintain it. If you upgrade and replace equipment but don't maintain it, you will find that your energy savings are short-lived. You won't achieve the return on investment that you expected. If you don't make energy savings a part of your routines, processes, and culture, a one-time push to be more efficient will give way to old wasteful habits. The graph tells the story of many energy efficiency initiatives. First, costs increased. Then you launch a few independent projects and you see some improvements. Once the projects end, your performance is good for a little while, but then you see costs rising again. This repeats. Energy management systems are designed to break this cycle. Energy management systems enable a company to lock in savings by making energy efficiency a part of its routines, processes, and cultures. This begins with small steps that require changes in behavior first. This sets the stage for making small investments in a logical progression, focusing first on where you get the biggest impact per dollar. This positions your company to drive continuous improvement in energy performance and achieve sustainable savings. It is also important to note that, as the graph demonstrates, the greatest reduction in energy costs comes from low-cost or no-cost actions, not capital investments. As an example, there is a specialty plastics manufacturing plant in upstate New York that is currently saving over $50,000 a year through low-cost or no-cost operational improvements with no capital investments. Those savings are the direct result of implementing an energy management system. So, what is an energy management system? An energy management system, or EnMS, provides organizations with a framework for efficiently managing and improving their energy performance, thereby reducing energy costs. An EnMS helps the facility establish the policies and procedures necessary to plan, identify, prioritize, and implement projects that will improve a facility's energy performance. If you structure the management of energy, like most organizations already do with finance, personnel, inventory, production, and quality, it ensures that energy efficiency is an important consideration in all your organizational decisions. I should note that the energy management system we're discussing right here should not be confused with building technologies used to manage energy, such as building automation systems, energy management information systems, and virtual audit software. The energy management system we're talking about is a set of interrelated elements to establish an energy policy and objectives, and processes and procedures to achieve those objectives. It's a framework for managing energy. The ISO 50001 Energy Management System Standard establishes a formal framework for industrial and commercial facilities and organizations to manage energy. It's the international standard for establishing and maintaining energy management systems. ISO 50001 is a volunteer standard that was published in June of 2011. ISO 50001 is based on the management system model of continual improvement, also used for other well-known standards such as ISO 9001 for quality or ISO 14001 for environmental management. This makes it easier for organizations to integrate energy management into their overall efforts to improve quality and environmental management. It is designed for implementation by any organization of any size. Formal recognition of a company's EnMS is accomplished using the ISO 50001 standard, the Superior Energy Performance Certification, and the Department of Energy's new 50001 Ready designation. SCP is a more rigorous energy performance certification developed by DOE that requires verified energy performance improvements. 50001 Ready is a designation for organizations that have implemented an ISO 50001 based EnMS using the 50001 Ready Navigator online tools. 50001 Ready is great for companies that want the benefits of an EnMS without the ISO 50001 certification costs. PennTAP has been helping clients with energy management systems from the beginning. Our first success story was the first ISO 50001 and SCP certified facility in the US, Volvo trucks. With PennTAP's guidance, Volvo involved a variety of employees on its energy team to improve its energy performance by more than 25% over 3 years. Volvo saved over $800,000 a year with a 5-month return on their investment. Granted, this was a large-scale project with large dollar values, but the great thing about energy management systems is that they work equally well for small organizations. You can realize the same percentage improvement in your energy use. With an energy management system in place, you are now ready to take the last step on the road to renewables and consider renewable energy options. We will briefly discuss the clean technologies listed here and focus on the opportunities for small and mid-sized organizations in Pennsylvania. We'll cover solar, wind, anaerobic digestion, biomass, combined heat and power, and geothermal heat pumps. Solar energy installations are likely what you see most often. The equipment is easy to recognize and often installed in a prominent location. This visibility is a selling point for businesses that want to put their commitment to renewable energy on display. Its value as an energy asset does depend on local weather patterns and the sun exposure available at your site. If you are unable to use your rooftop, you will need open land. A location with the southern exposure provides the most direct alignment with the course of the sun across the sky. Within Pennsylvania, the south and east generally get the most sun compared to other regions. Photovoltaic installations have few or no moving parts, and therefore low maintenance requirements. They also can automatically manage power production and demand. They will mix solar power and grid-supplied energy when site demand exceeds the solar energy supply, and can sell energy back to the grid when the solar energy available exceeds the site demand. This makes solar an attractive option for favorably located facilities that want renewable energy with plug-and-play convenience. Keep in mind that output will vary day to day and seasonally, so the amount of solar power you will actually be able to use on-site will depend upon your demand profile. Pennsylvania's solar energy potential is lower than what you will find in the southwestern United States, so it's important to get a realistic estimate of how a system will perform at your site before you make an investment. You may be considering wind power as an alternative or supplement to solar power. If so, your geographic location will again be a significant factor. This map shows the most suitable areas for wind power in the state in tan and brown. The best areas are in the northwest and northeast portions of the state. The mountain ranges in central Pennsylvania also offer a narrow band of relatively good wind speeds. However, the majority of the state does not offer ideal siting for wind energy. Across the country, the greatest wind potential is concentrated in the Midwest. In the next few slides, we would like to talk about a few clean energy options that receive less attention but may be of particular interest for organizations in Pennsylvania. Anaerobic digestion is one renewable energy technology that receives less attention than solar and wind. However, it has unique characteristics that can make it more attractive in certain applications. As the name suggests, this technology uses bacteria to digest organic waste and produce useful byproducts, including methane. A combination of naturally occurring bacteria break down animal waste, in this example manure, and produce methane gas. People have been harnessing gas produced in this manner since at least the 19th century. Basic anaerobic digesters are widely used in India and China to produce fuel for cooking and light. Modern anaerobic digesters use vessels that can accelerate and control the methane production process. The resulting gas production is sufficient to provide fuel for a generator. Most small applications use reciprocating engines, but turbines and fuel cells can also be used. The process also reduces odors and concentrates nutrients into a liquid that can be used as fertilizer. Food production wastes, such as waste whey, can be combined into a feedstock for anaerobic digestion to increase methane production. Anaerobic digesters can provide and operate as long as organic waste is available, day or night, and throughout the year. Digesters can be complex and require monitoring and maintenance to function reliably. Pennsylvania's dairy and food industry provide good opportunities for anaerobic digestion installations. Biomass is another waste-to-energy opportunity that can be a good fit for businesses that generate or have access to suitable waste streams. Waste wood from forestry operations, sawmills, or cabinet makers can be used in a suitably designed boiler. Some boilers are designed to use pelletized wood that can be automatically fed into the boiler. Biomass boilers can provide heat or power if used in a combined heat and power system. We will talk more about combined heat and power in the next slide. Combined heat and power, or CHP systems, supply both heat and power using an integrated set of equipment. The main benefit of this approach is increased efficiency. On average, electricity and heat are generated at a rate of 50% efficiency when provided separately. One reason for this is that electricity generation often produces heat which cannot be completely converted into electricity. Unlike electricity, this heat can't be easily distributed to distant end users. CHP installations solve this problem by producing electricity at the end user's location. Heat co-generated with electricity can be harnessed and used at the facility. This can be particularly useful at facilities that require process heating, as well as heat for buildings. These systems can operate at efficiencies of 65 to 75%. They can also provide redundant power and heat for critical infrastructure that cannot tolerate power interruptions, such as hospitals. CHP systems can use a variety of fuel sources, including natural gas, anaerobic digestion gas, or biomass. Geothermal heat pump systems are another clean energy technology that receives less attention but may be of particular interest for facilities in Pennsylvania. They are mainly used for heating and cooling. These systems take advantage of the fact that temperatures underground do not vary much throughout the year. In the winter, the ground tends to be warmer than the air, and in the summer, the ground tends to be cooler than the air. Geothermal heat pumps take advantage of this temperature differential to provide heating or cooling using less energy than conventional alternatives. They circulate fluid through pipes buried underground. The fluid temperature then approaches that of the ground. In hot weather, the fluid will be colder than the air and can provide cooling to the building. In cold weather, the fluid will be warmer than the air and can provide heat to the building. Two styles of construction are shown in the slide. One uses deeper vertical loops, while the other uses horizontal loops. These systems can be expensive to install, and the type of installation needs to match the conditions of the site. These may be most attractive for new construction rather than retrofit. That concludes our discussion of energy efficiency, energy management, and renewable energy options. In the next few slides, we will cover several funding opportunities that can help you cover some of the costs of improving your efficiency or installing renewable energy systems. The first option we'll discuss is the Small Business Advantage Grant Program, or SBAG. SBAG is a popular program with PennTAP clients. It is an energy efficiency initiative of the Pennsylvania Department of Environmental Protection. SBAG reimburses eligible applicants 50% of their project costs, up to a maximum of $7,000 for lighting-only projects, and $9,500 for all other projects. To be eligible, an applicant must have fewer than 100 employees, and the project must achieve energy savings of at least 25% with over $500 in savings. In-house maintenance costs are ineligible. Grants are awarded on a first-come, first-served basis. The Rural Energy for America program, or REAP, is another option for grant funding. This program is administered by the United States Department of Agriculture. The grant incentivizes energy efficiency projects with potential awards of up to 25% or $250,000. Your company has to qualify as a rural small business. Grants are awarded based on a 7-criteria scoring system. Criteria include points for first-time applications, percentage of savings, renewable energy sources, and length of payback. Applications are accepted year-round, with awards taking place semi-annually. For other sources of funding or incentive programs, the database of state incentives for renewable energy, DESIRE, is a very useful online resource. It is the most comprehensive source of information on incentives and policies that support renewable energy and energy efficiency in the United States. Established in 1995, DESIRE is operated by the North Carolina Clean Energy Technology Center at North Carolina State University and is funded by the U.S. Department of Energy. DESIRE lists rebates, grants, loans, and tax incentives for each state. There are a number of grant and loan opportunities in the Commonwealth Finance Authority programs. These are managed within the Department of Community and Economic Development's Office of Business Financing. These programs were made possible by the Alternative Energy Investment Act, which was signed into law in July 2008. The programs provide grants and loans to clean and alternative energy projects, including buildings, equipment, and land development activities, individuals and small businesses for high-performance, energy-efficient building projects, geothermal and wind energy projects, and alternative energy production projects involving solar technologies. The High Performance Building Program helps to build LEED certified buildings. The Renewable Energy Program is only for geothermal technology development and wind energy. The Solar Energy Program provides grant loans for solar projects. The Alternative and Clean Energy Program provides funding for clean energy equipment or component manufacturers. The Pipeline Investment Program provides funding for companies to have natural gas lines brought to their manufacturing facility. This concludes our discussion of financing and grant sources. I would now like to provide some additional information on PennTAP. PennTAP services fall into 2 categories. The first is provided by the Energy and Environment team and includes pollution prevention and energy efficiency, or P2E2 assessments, economy, energy, and environment, or E3 assessments, energy management systems, or EnMS, and building retuning, or BRT. The second category is what we call innovation services, which include product and process improvement, the learning factory, and student engagement and entrepreneurship. In a pollution prevention and energy efficiency, or E2P2 assessment, our technical advisors will perform pollution prevention and energy efficiency on-site visits, provide recommendations for improvements in energy utilization and waste reduction, prepare and deliver site assessment reports, and provide assistance completing grant applications for project implementation. An E3, or Energy, Environment, and Economy Assessment, is designed to help Pennsylvania manufacturers define and implement strategies designed to improve energy, environment, and economic efficiencies. It aims to increase the adoption of E3 practices by conducting a comprehensive set of activities led by experts in production efficiency, environmental, and energy practices. It features activities in which lean manufacturing techniques are applied to focus on energy and environmental issues. It includes E3 training for a team of employees, followed by facility P2E2 assessments conducted under the direction of a PennTAP technical advisor. It utilizes resource partners specializing in lean manufacturing techniques to assist with the assessment. PennTAP also helps organizations establish energy management systems, or EnMS. We described EnMS systems previously in this presentation. We also offer building retuning. Building retuning outlines a systematic approach for evaluating building performance and identifying low-cost or no-cost opportunities for reducing energy waste for community colleges, K-12 schools, municipalities, and government buildings. BRT includes classroom training on the fundamentals of retuning, then a building walkthrough to identify savings opportunities and create recommendations. In 2016, PennTAP's Energy and Environment team performed 64 P2E2 assessments, 2 E3 events, 11 building retuning, or BRT, coaching and training events, and educated hundreds of individuals on various energy and environmental topics. This work resulted in economic benefits totaling more than $1.1 million, the elimination of over 3.6 million kilowatt hours of electric use, a 15,000 million British thermal unit reduction in natural gas usage, and a reduction of greenhouse gas emissions equivalent to eliminating 534 passenger vehicles. PennTAP is in year 2 of a current 5-year USDA University Center program to enhance and build economic development in Pennsylvania by leveraging Penn State resources with businesses and community partnerships. We do that by engaging students and faculty in technical, design, and operational efficiency projects to help entrepreneurs and intrapreneurs overcome hurdles. There are 17 innovation hubs located at PSU campuses around the Commonwealth to help with new business and new project creations. The Learning Factory does over 200 student team engineering design projects every year to help sponsors advance technical challenges toward viable solutions. There are mechanisms in place to allow sponsors to retain all intellectual property that might be of value to the organization from the sponsored project. The Learning Factory has been engaging students with company sponsors for over 22 years. The Learning Factory allows students to demonstrate before graduation their abilities to perform in the work environment. It allows organizations to build engagement networks with faculty and staff within Penn State, and allows small companies to benefit from inexpensive but high-quality engineering services. It also allows companies a longer-term interview with potential students they may want to hire after graduation. Each year, we're reaching more organizations and expanding our impact. By partnering with the Invent Penn State initiative, our ability to help organizations and entrepreneurs has broadened significantly around the Commonwealth. The INCU student entrepreneurship efforts have helped advance many student companies to the point that their student founders are working full-time after graduation, building their companies within Pennsylvania and beyond. We have several upcoming webinars and workshops shown on this slide. These can also be found on our website. We would now like to turn to our chat interface for questions, but before we do, thank you all for taking time out of your day to join us.
Hi, John. My name is Royal Smith. I'm a technical advisor with PennTAP, and it looks like your question is about the 2012 Excel sheets we put together, probably from someone named Mark Toda helped you with them. And if you send Denise an email whose contact info is on there, you could also send me an email, which is at royal, R-O-Y-A-L, @psu.edu, and we'll be able to help you use that spreadsheet. We'll probably help you in a different way since the 2012 spreadsheet's a bit outdated now with prices and some other information. So if you send Denise or I an email with a little bit of background, we'll be able to help you with your solar project. And for Robert, yes, we'll send you an email with a copy of the PowerPoint as well as a recording of this webinar will go up on our website within the next week. Hi, John, my name is Royal, R-O-Y-A-L, @psu.edu. That's my email address. It's that nicely simple. So if you can give me an email there, I'll follow up with you to get more information about what your solar project is. Okay, there is a question about anaerobic digestion and safety systems. Unfortunately, we're generally not able to aid with township rules and regulations. What we'd probably be able to assist with, Mike, is providing information to the township nearby. So we could help you figure out how much energy it would save, as well as sort of some of the avoidance issues. So I unfortunately don't know much about your site, but some sites we've worked with that have anaerobic digestion, there were some odor issues beforehand. And once you put on the anaerobic digester, those odor issues go away. So usually townships are happy to have this come along. And Mike, we'll make sure to reach out to you for the assessment information at a later date. We'll have your email address from when you signed up, so we'll reach out directly to you. So thank you, Mike.
Seeing no additional questions, thank you again, Royal, for helping us. And if you think of additional questions, feel free to email us at the contact information we've provided. And you'll also be getting a copy of this presentation emailed to the email addresses you provided when you registered. Thank you again, and we hope you have a good afternoon.